Okay, let's move on. Practical task 1, OP basics. We are given the description: develop a class field with full encapsulation whose attributes are accessed and data changes are implemented through method calls. In OP, it's generally accepted to start with names of methods for extracting data with the word get and the names of the methods in which fields are equipped to a certain value set. In this task, you need to implement getValue and setValue methods for field class with value property, underscore value property. Okay, you should create a class field and with value underscore value none, and underscore value, it means it's a private. You cannot access by itself, like simply you cannot access. So in order to and for this we create two functions, getValue and setValue, to access this private variable. Simply getValue and pass the self. You should always pass the self in the functions when you create a class in Python, and then just return for getValue, just return the self value, this value, private, and for setValue, pass the self and new value here, and assign new value here to our self underscore value, our private value here. It will update it. Initially it's none. Okay, here's the example. Create a class, call the class, create instance and call the class and then set value 42. It will set, and you can now print it out, get value, and then here also set value 43 and get the value. It will return the value. In our case it's 43. It will return the 43. And set value string, it will return the value string, because it could be anything. We did not declare data type like string or integer, like, and because of this it can handle string, integer, float, everything. Let's test it. Print, just print the values. Okay. And here you can send the results 42, 43 and value. Well done. Let's move on. Practical task 2. Description: create a class school member which represents any person in the school. Classes, teacher and student are inherited from school member. Classes should have the same inheritance with public show method or function. Teacher accepts name string, age integer, salary integer, and student accepts name string, age integer, and grades. You can see here there's no data type. Move the same logic of initialization to the class school member. Method show return string. See the string parents in example. Let's see the example. We create the instance person. We create a new variable person and call the class teacher, passing the name, age and salary, and for student name, age and grades. And now for each of them, because this is the list, we can iterate over this. Just for person and persons, print person show. It should show name, age and salary. Okay, for this we should create firstly school member. Let's that will be inherited from teacher. Firstly, we should create a class school member, and then we can inherit teacher and student from school member. Okay, initialize name and age here, and just function to show name and age. Now we should create a new class, teacher, and inherit from school member. And we should also call the initializer of school member. For this, we simply use super parentheses and init name and age, and salary we will get from here. And now we can simply inherit the function show and return the name, age, and salary. And for student, this is the same scenario, but except grades. Here we create a new function show and return the name, age, and grades. Why we have there two, name and age, not salary, not grades. Why? Because in school member initializer we just pass it we initialize the common attributes like name and age, because name and age both teacher and student has, but salary is only for teacher and grades for student. Let's see. Python 3 task 2. Okay, let's print this. Okay, let's print. Okay, we have a result: name Mr. Snape, age 40, salary 3000, and name Harry, age 16, grade 75. Let's move on. Practical task 3. We are given implement a counter class that optionally accepts the start value and the counter stop value. If the start value is not specified, the counter should begin with 0. If the stop value is not specified, it should be counting up infinitely. If the counter reached the stop value, print maximal value reached, just message. Implement two methods, increment and get. To increment and to get the result, return the result. Okay, here is an example. Create an instance and call the counter class. Pass the start value 42. There is no stop value, so it will count infinitely. But here we have a start value and also stop value. And when you call increment and then get, it will show the 43, but when you again increment, it will show the message maximum value is reached, because we passed the stop value. Okay, how we can implement this? Firstly, create a class counter and define initialize variables start, stop, and current value here. Yeah, and stop should be none, and start initial value should be 0, as it said here. And then we should create two methods, increment and get. Increment simply will increment the start value. Increment simply will increment the current value. Like, we will firstly check if stop is not none and self.current is equal to self.stop. If this is true, we should print the maximum value is reached. It cannot exceed from stop value, given the stop value. But else, we should increment the value. Self.current plus equals to 1. It will increment by 1. And next method, get, simply return the self-current value. Let's test it. Counter, increment, get, and then counter, let's start 42 and stop 43, and increment, get the value, increment one more time, and get the result. Let's see. Python.3. task 3. Okay, we have a result. As you can see here, we got 43. It's this first, and then also 43 from here. We are calling the increment and then printing the result. We got 43, and then when we increment one more time, we got the result. The maximum value is reached. Let's move on. Here is a practical task 4. We are given the description: implement a custom dictionary that will memorize the 5 latest changed keys using the method getHistory. Return this case example history dict, and we are passing the dictionary with key foo and value 42, and then we are setting the value bar to 43, and then get the history. It shows bar. Okay, how we can implement this? Firstly, let's import dq from collection. From collection import dq. Why we are using dq? Because here you can see dq is double-ended queue in Python, is implemented using the module collection. dq is preferred over the list. In the case where we need to quicker append and pop operation, because you can like from both the end and of the container, and dq provides, okay, you can add element to rear side and remove element from rear side, and also you can add element from front side and remove element from front. Let's create a class history dict and initialize our history and data. Firstly, we should check if data is none. If data is none, we are given no data, we should create a new, like, empty dictionary. And here simply use the dq and max length 5, because we need memorize 5 latest changed keys. Okay, now we should create 2 methods, set value and get history. And the set value should get k and value, like where to set and which values to set. Here we are saving a dictionary k, like with a given k and value, and appending the history only k, as it said here. And then on a get history, we just return the history, but as a list, like here. Let's check this out. Get history. Okay. Python.3 task 4. Bye. Now here you can see we get the result bar